In today's video, we're going to be talking about Newton's second law. Newton's second law states that if an object has a greater mass, then it needs a greater force for it to accelerate. Newton's famous formula for the second law would be F, or force, is equal to m times a, or mass times acceleration. Mass is the amount of stuff that's in an object. Don't get mass and weight confused. We will talk about it in the next video. Just remember that mass is the total amount of matter in an object. So let's demonstrate with some examples. So we have a water bottle filled with water, and we have a water bottle with no water at all. We can obviously see that the one with water has more matter because it has more stuff inside of it. So I'm going to be pushing it with both of my index. And with my index, I'm going to be applying the same force on both. Let's see how far each one travels. As you can see, the lighter one over there went all the way to the end of the table, while this one barely moved. So over here, you can see that this one has more mass. It needs more force for it to also be able to move to the end of the table. That is known as acceleration. So now let's move on to Newton's cradle. We can see that already from first glance view that each ball will probably have the same mass. From the formula we previously explained, we said that force is equal to mass times acceleration. If we know that they have the same mass, and if we're applying the same force, then we can easily tell that the force will be applied to each ball, and the end balls will probably swing back and forth, hence creating the same force again and again. With this will create our acceleration. We will try with one ball, two balls, then three balls. So for the first ball, we're going to be swinging it over here. Just like our prediction, it flew back. And what happened is the way it flew back was because we applied the same force here, and because of their same mass, the equal force was easily applied to all of these. And because this was the last ball and it didn't collide with anything, it flew out, hence coming back again and having the same thing happen with this ball. So both balls have the same acceleration if they have proper mass and force. So if I just did one ball, then the last ball will swing. What if we do two balls? What happens is with the mass of two balls, that means that it has enough amount of force to pull these other two balls too. And same with three balls. What happens is that if we want to equalize the amount of force from one part to another, the middle ball is actually alternatively going from this side to this side over here. Hence three balls. The same with four balls. We can see that just like what we did with three balls, because it has the force of four balls, what's happening is that these three balls in the middle have to alternate with these two balls from one side to another. This is how Newton's second law works with the Newton's cradle. Okay, so let's see these ping pong balls. Okay, so these are two ping pong balls over here. So they have the same mass, meaning that just like how we did with the Newton's cradle, they will collide with each other. They will probably have the same mass and speed. And that's correct. However, let's use something else, like a rubber ball. This one has more mass, so let's expect the speed and acceleration. Okay, so as you can see, the rubber ball, instead of like the other ping pong ball, it didn't change the direction. It just stayed where it was because the mass of this small rubber ball, because it was bigger than the mass of this ping pong ball, the ping pong ball kept hitting it only to be reflected back. So the rubber ball and the ping pong ball didn't move with the same direction and speed. Hence, they stopped slower and there wasn't any acceleration. Whereas with the ping pong balls, they're moving away with the same speed and direction.